Hello students, in this video I am going to discuss another reaction map where I am going to discuss the important reactions of alkene. When this alkene is treated with H plus water, it's called hydration of alkene. That means we are getting alcohol. So here OH attacks to the more substituted carbon and H plus, the electrophile, attacks to the less substituted carbon. We can get similar type of alcohol when it is treated with mercuric acetate with water followed by sodium borohydride. It is called oxymercuration demercuration. Same alkene when it is treated with B2H6 followed by hydrogen peroxide and sodium hydroxide. Here we are getting alcohol, but alcohol will be different. Here OH, the nucleophile, attacks to the less substituted carbon and hydrogen attacks to the more substituted carbon. This reaction is called hydroboration oxidation. When alkene is treated with bromine water, here cyclic bromonium ion forms. Here Br attacks as a electrophile and water molecule attacks as a nucleophile. So it is a halohydration. So Br attacks to the less substituted carbon and OH attacks to the more substituted carbon. When we treat this alkene with bromine carbon tetrachloride, so here also cyclic bromonium ion forms and then we get trans addition, means vicinal dihalide. HBr reacts with the alkene. It also follows Markovnikov's rule. Nucleophile Br minus attacks to the more substituted carbon and electrophile H plus attacks to the less substituted carbon. So we are getting alkyl halide. But when we perform this reaction in presence of hydrogen peroxide, here also we get alkyl halide, but here addition will be different. Here nucleophile Br minus attacks to the less substituted carbon and hydrogen attacks to the more substituted carbon. It follows anti-Markovnikov's rule. Mechanism is free radical reaction. When alkene is treated with ranitidine nickel hydrogen or palladium charcoal hydrogen, it undergoes reduction, means across the double bond hydrogen attacks. So here we are getting from alkene to alkane. Next reaction is the oxidative cleavage, where carbon-carbon double bond breaks and we are getting ketone and aldehyde. Left hand side portion gives the ketone and the right hand side portion gives the aldehyde. So this is the acetaldehyde. But when we perform ozonolysis followed by oxidative workup, the left hand side portion gives ketone but the right hand side portion gives the acetic acid. Same product we get when it's treated with hot alkaline KMnO4. But if we use cold alkaline KMnO4, cis hydroxylation takes place. That means OH attacks across the double bond and it attacks cis position, so we are getting vicinal alcohol.